So I want to say this is actually particularly exciting for me to be talking about because this was work that Eric and I did in the early 90s, which ended up becoming my PhD thesis. But it ran into a little bit of a political issue at the Harvard Economics Department, as a result of which I didn't do very much work on it since then. My professional work since then has been in development economics. But fortunately, Eric has been working on it and has developed some of these ideas and developed some of the analytics. But it's very exciting for me to have a chance to go back and talk about the initial ideas that led us to this work. And since then, Eric actually presented this here at the Perimeter Institute a couple of years ago. And a few other people have picked it up. And I think there's been some interest recently in it. And it's really very nice for Eric and me to see this work finally be picked up after all these years. I've titled the talk, A New Marginalism, Gauge Theory in Economics. The economists in the room are familiar with, I'm sure, the marginal revolution, the introduction of differential calculus into economics, which ended up really forming the basis of neoclassical economics and all the analytic work we do. And what Eric and I are trying to say with this work is that we can bring in gauge theory as an additional set of tools which allows us to take the marginalism one step further and answer some questions, deal with some basic assumptions, fundamental assumptions that neoclassical economic theory has made that really aren't valid. And the reason we claim they make these assumptions is that they can't really deal with the technical issues involved with relaxing the assumptions to get to a more realistic place. And we claim that if you actually bring gauge theory in, you can introduce the next marginal revolution, a new marginalism that allows you to deal with some of these very basic assumptions. So since we're talking about the fundamental assumptions of economics, I just wanted to start with some basic definitions of economics. And one of them that most of us are familiar with is this notion of maximizing under constraint, maximizing with scarce resources. And the Lionel Robbins 1932 definition is one that most of us learned as undergraduates in economics. But in the 1970s, we started seeing definitions that looked a little bit different. If I look at this definition from Gary Becker in 1976, I see something that looks just a little bit more defensive, shall we say. Becker throws in things like stable preferences and claims that we need to use these relentlessly and unflinchingly, and that it needs to form the heart of the economics approach. And one has to ask why stable preferences needs to be such a fundamental part of our assumption of economics, something that needs to be written into the very definition of economics. And I think the answer is, oops, sorry. I will adjust to this. This is Eric's computer. The answer is something that we see explained a little bit more when we look at people who actually deal with we look at some of the comments of people who actually deal with changing preferences more in depth. This is a quote from Carl Christian von Weizsäcker, and he points out that we've worked with the assumption that preferences are stable, are fixed, because he starts by saying that we work with this assumption even though it's never been accepted by anyone outside of the field. However, it really represents such an intractable problem to economists, given our current set of tools, that we have been forced, in some sense, to make this assumption. Well, how do we deal with the fact that changing preferences presents such a huge problem to economics? We could do what Gary Becker did, which is essentially define away the problem. Some of you saw this quote yesterday in Eric's talk. we can just decide that one doesn't argue about preferences, just like one doesn't argue about the Rocky Mountains. They are simply there. And it was actually when Eric and I were working on this, we kept coming up with this issue of changing preferences and people referring to how Becker had dealt with the problem of changing preferences. And it was very interesting for us to find that Becker had dealt with this problem by simply asserting that preferences were like the Rocky Mountains. Another approach we can take is, we see an explanation of this in this quote by McPherson, where McPherson basically admits that no one has ever really been able to deal with changing preferences within our traditional theory, which is why we've simply just defined them out. Sorry? Yeah. We were trying to figure out where 2,500 years leaves us. That's actually, yeah. Okay. The next solution is we can simply ignore the problem and hope that no one notices, which is essentially what we do when we go through the process of most economic theory. We do our models, and we don't comment on the fact that we've assumed unchanging preferences. Or we could do what Eric and I did, which is that we can actually try to think about changing preferences within this new framework that we've talked about. And this really gets to the heart of what we're trying to do. The very basis of economics relies on income and substitution effects. Economic analysis, neoclassical economic analysis, can be boiled down to thinking about income and substitution effects. And the claim is that if you just extend our current calculus tools to allow us to separate out income and substitution effects, you can, in fact, deal with this idea, this assumption of changing preferences. You can allow preferences to change. And when we think about income and substitution effects, we can see it in terms of trade-offs versus increases and decreases. We can see it in terms of market consumption. If you think of the budget constraint, that represents a trade-off, a substitution, whereas purchasing power changes represent increases and decreases in income effects. You can think of it in terms of welfare. Movements along the indifference curve really are substitution effects. Movements to different indifference curve shifts in utility are income effects. Similarly, with production, you have shifts along your production function, or you have growth. And then when we start thinking about the geometry, we talk about how you can decompose your space into horizontal and vertical subspaces. And I'll talk about that a little bit in a few minutes. Let me just very briefly, I apologize to the economists in the audience, but give you a 3-minute condensation of all of Marshallian demand. The first graph shows you preferences. It tells you how a consumer is expected to behave given their preferences. I've used the example of beef and chicken, which is the example used by the Boston Commission when they were trying to figure out issues around the consumer price index. And the indifference curve A represents, each point on the indifference curve represents a different basket of chicken and beef. And you will trade off, you're indifferent between any basket along the indifference curve A. And it has the shape it does to represent the diminishing marginal returns issue that Brett brought up yesterday. The more beef you have, the more willing you are to trade it off for chicken. And then as you shift from one indifference curve to another indifference curve, as you move to a higher indifference curve, your income is, your welfare is increasing, your utility is increasing. The budget constraint represents the market, and this is the trade-off that you find within the market. You have the price of beef on one axis and the price of chicken on the other axis. You could choose to spend all your budget on beef or all your budget on chicken, or you can trade off based on what prices are available in the market. So you move along, the market defines how you can move, how you can substitute between chicken and beef based on prices. And then Marshallian demand tells us that the consumer is going to maximize by finding the highest indifference curve tangent to whatever budget constraint they're faced with. Um, Let me then shift to talking a little bit about welfare measures in economics, and measuring not just welfare, but measuring inflation, because we tend to think of index numbers as duals. We have price indices and quantity indices, and price indices will measure inflation, quantity indices will measure growth. Given that we don't actually have access to preference maps, we take what we have, the information that we have available to us, namely the prices in the market and the quantities that people actually buy. And economists have come up with various mechanical index numbers to evaluate changes in prices or changes in growth. We have just listed here a series of index numbers. There are several others. The question is, how do you choose between these different index numbers? Irving Fisher in the 1920s came up with the test approach, and he listed a series of axioms which seemed reasonable for any index number to fulfill. The only problem was that in 1930, Ragnar Frisch proved that no index number can satisfy 3 of the basic Fisher axioms. So you have a little bit of an issue with the test approach. Sure. Yes, thank you. So let's talk about that. That is the Las-Peres index, and that is actually the index that is used to evaluate consumer price indices, and it's the most basic, essentially, index that we use. So I have here a price index which says P1 over P0. So Q0 will be base time baskets. It's the basket you consume at time 0. You want to see what's happened to inflation. So let's say you're looking at your 1960s basket, and you're looking at 1960s prices. You want to see what that basket, what the inflation has been in the last 40, 50 years since then. So you evaluate your basket that you consumed in 1960 using 1960 prices. And then you take the same basket, your 1960 basket, and you evaluate it using current prices. So P1 is our current prices, and these are base time baskets, and that's base time prices. Okay? The PASH is going to be if you use current time baskets. So you take today's basket, you see what it would have been worth in 1960 prices and what it is today. So this actually brings us to the heart of the problem. How do you take your 1960s basket and evaluate it in today's prices? What if you have something like a typewriter in your 1960s basket? Well, you can try and figure out what a typewriter is worth in today's prices. It just really doesn't make a lot of sense. You could try decomposing it. We use something called hedonics, where you can say, what are the computing values? What are the qualities that a typewriter possesses, and how do I value that? You get into a range of issues. But essentially, what Eric and I point out is that somehow economists have taken this base time basket and they have brought it into current times. How have they done that? The claim is that they've done that using a connection. However, it is simply the trivial connection. So we have a notion of constancy. And the notion of constancy, which we've used in this case, is to simply take exactly the same basket that we had in 1960 and evaluate it in today's prices. It's a constant basket. It's exactly the same basket. What if we have the ability to think about something that is economically constant? If we have the ability to create a connection that lets us change something in a way that is economically constant, but allows us to actually update our basket to be relevant to today's times. And the whole point is that if you actually develop a connection that allows you to shift your basket by economically allowable substitutions, what you do is you get rid of the index number problem. If you take the quantities and you parallel translate them using the appropriate gauge theoretic connection, in fact, the differences between all these index numbers disappears, and you end up with the same index number. So as a non-physicist, I'm going to try and explain a little bit of what we do, and I will let Eric actually talk about the more technical aspects of this. But essentially, what we've done is we've decomposed our space into income and substitution effects. So we have the subspace denoted by Q, by our basket, and then the barter space, beta sub P, which is the space of all economically worthless baskets given the current pricing system, or all barters given the current pricing system. And the claim is that you can take any vector and you can decompose it into the portion of the vector that lies on the subspace Q and the portion of it that lies on the subspace beta P. And that way you can allow your vector to change. You can allow changes over time as this vector moves through time, and you keep track of the change in the vector along your Q subspace, and you allow it to change by barters. And at the end of the day, if you look at the size of your vector V relative to your vector Q, you're going to have a sense of the change in the income having held substitution effects constant. So you've allowed your consumer to change from 1960 by substitutions, allowable by whatever the prices are available in the market at any point of time. However, only by substitution. So in that manner, you've held the income constant. You've held your consumer at exactly the same level of income. However, you've allowed him to change by substitution effects, by barters. So this is what we call an economically constant translation, parallel translation. And the claim is that this allows you to solve the index number problem.
And this barter could happen at any point in the delta T.
The delta T.
The time periods.
Well, actually, the claim is that the individual is going to be constantly, they're moving along a time path. So you're constantly allowing them to change their basket, and they are constantly going to be moving along this path, changing by substitution effects.
I'm just trying to see how we get rid of the accounting problem with one typewriter. I mean, at some point, I elect not to replace my typewriter, and instead I get a word processor. But my word processor is doing a bunch of other things. And then I have to somehow price that up between my printer and the part of my word processor that's doing those other things. So
right. So you're consuming a basket,
yeah.
right? Presumably it's more than one good.
Right.
And you've got a budget constraint. And you're allowed to shift that basket from whatever items are in it. And you're allowed to take whatever you were spending on a typewriter versus other things. And you're allowed to shift from your typewriter to buying a word processor, a computer.
So I understand the idea. I just pointing out there's still an accounting problem of how much I'm going to allocate to the substitution for the typewriter. It's not obvious to me when I switched over to a word processor for the first time how much of that was actually a typewriter substitution and how much of it was substituting a bunch of other things that I did with my word processor. If I'm playing video games or something, heaven forbid I hate video games, but it would be, how does that figure in?
Right.
Because the problem is, theoretically I don't see any problem.
Yeah.
I'm just saying, does this really solve? So if I'm a macroeconomist, is this really going to help me figure this out?
It is. You take your basket for, the representative consumer and whatever your representative basket is, and then you allow your representative consumer to shift along it with their entire basket. So you're changing your entire basket and your entire set of consumption. It's going to include food items. It's going to include computers. You're trading off with a bunch of different things. So it's not. Do you have?
I'm just trying to figure out maybe the new goods question. The issue of you put in the giant vector space that includes goods that haven't been invented, and then you come up with fictitiously high prices, or you don't worry about that because the consumption is zero.
I don't think that's Tony's question.
Maybe
we can come back to it, but as an outsider take, the point is that the consumer in this game is free to make whatever substitutions they want, as long as one correctly takes into account the decomposition into what's cost-free at a given moment, which is in the subspace beta, and what is not. That has implications. The fact that the claim that they're free, they're free, or there are other considerations that determine what the preferences of the consumer are as they're changing. maybe after the whole thing is over, we can come back and look at the
Okay.
implications of this.
Right.
Well, here is one of the problems that arises with this. First of all, I should say that in the simple case of the index number problem, if you have unchanging preferences, all the other index numbers collapse to the Division index. The Division index has been around since the 1920s. However, economists have never been comfortable with it, primarily because the Division index represents an issue with path dependence. You are going to have path dependence with the Division index. And economists see path dependence as a problem. They see this as being a flaw. The issue came up yesterday, and the physicists were talking about the fact that you learn to deal with, you learn to log path dependence in physics once you understand the role it's actually playing. Economists haven't quite gotten to that point yet. So one of the big issues that we've been dealing with is that this is all fine and well, but you're going to end up with a path dependent index.
I just need to say one thing. I mean, in defense, we do, of course, we use chain index for GP.
We do chain indexes, and they have path dependence
And Bill
issues.
Barnett has been working on this for a long time. I mean, there are economists who, and I myself think because the indices are the most general form of index. I mean, I think of everything else as just picking a particular path between 2 points. I mean, in terms of approximating
Right.
the path. But I mean, so I don't think we're against. I've never heard any
Well,
economists.
I mean,
What's the name
right
of
there,
it?
you can,
I never heard of
This
this.
is here. Yeah,
I don't know, but easy
It's
is
the last one.
Easy, the last one on the list.
Yeah.
no, in fact,
I mean,
Fisher,
they're considered to be a very high level
well, wait,
For
index. I mean,
you're running like a classy friend.
and when you think about the issues, I should say, when we were working on this, this was around the time of the Boston Commission, and this represented some of the political issues that we ran into. But there was very much a sense that you don't want to get into chaining indexes too far because of the path dependence issues.
You might
I think it
want
was
to
meant
show
to
the
correct
formula
that. I don't
again.
know, yeah.
It's on the list.
Right.
Should just come up which one to show people what the division index is.
Yeah.
That's what
This is
that's.
the
That
Division
last-
index.
Yeah, yeah. It's the one that takes full.
Okay. So let me just talk about a couple of the welfare issues that I believe that this deals with. So as I said, we were talking about this around the time of the Boston Commission, and the Boston Commission was trying to deal with the overstatement of the CPI, the cost of living overstatement of the CPI. And what does this mean? If you think back to the indifference picture we were talking about earlier, if you're consuming at point A and you have the red budget constraint, and then prices shift so that you have the black budget constraint, the cost of living adjustment would compensate you for the new prices so you could consume your basket A. However, if they were going to give you enough money to consume your basket A, you would undoubtedly shift to a higher indifference curve and consume at point C. So what they would like to do is compensate you so that you end up on the same indifference curve and you consume at point B. This ended up representing a non-trivial sum of money. I believe they were talking about $1 trillion over 10 years. It was something that Congress was involved in, the Bureau of Labor Statistics, the Boston Commission. It was a fairly big economic and political issue at the time.
You might just note that the reason it's such a big issue is that the CPI is used for indexing the increases in Social Security payments, which is a big part of the total budget.
Right.
So what was going
Huge
on was
entitlement
so
programs.
they wanted to
That's right.
reduce the rates of those increases. That's the big money that's
And people didn't
involved. So
trust
why
it.
it's politically
And
sensitive.
the estimate was what? He was overstating about 1 to 1.5%.
Right.
People didn't trust it.
Well,
They claim it was 1.1%. Now, that number, I have been led to believe, actually was come up with even before the analysis was done. So, you can imagine that it ran into a fair amount of trouble.
Just a question for us non-experts. The estimation was off by 1 part in 100, or the issue was 1% of cost?
That the index, that the CPI had been consistently overstating inflation by 1+
1.1%.
So that's
at a time when inflation has varied between, say, 2 and 10%.
So that's between a 50% and a 10%
Yes.
error. So it's not a 1% error.
No, that's pretty big.
Yeah, it was very significant.
No, and
Yes.
what Robert Gordon has now come out with is that 1.1 was a number that Dale Jorgensen had come up with by figuring out what it would take to save 1 trillion, a round number, over 10 years, a round number, and 1.1 is what you back out.
I love reverse engineering scholars.
But of course, fortunately for the Boston Commission, they all agreed on the 1.1% number, and miraculously all came to it together. So, okay. The second welfare issue is the issue of changing tastes. And the question is, why is changing taste such a big issue for economists? You can see that it represents a little bit of a problem. If you're moving along your indifference curve from A to B, and your preferences shift, and you move along your curve from A to C, C is a multiple of A, so you could see why this would represent a little bit of a problem in terms of calculation. So what would it mean to actually deal with the changing preference problem? You're going to have to find a way to match your period 1 preferences, the individual indifference curves, to your period 2 preferences without relying on cardinal utility, declared cardinal utility. And it turns out that, Eric and I actually figured out that you could do this theoretically, and Eric has worked on it since and actually developed the equations that lead us to the point where you can do this. Now, the folks this was actually, I have to admit, as an economist, a little hard for me to visualize, conceptualize. I struggled with it for a long time to really get an image of how it worked in my mind. But our friends at NPOD actually have worked with Eric to try and come up with a way to...
I don't understand the problem yet. I mean, why is it hard to match those two sets of curves together? I mean, they're ordered in the same way, aren't they?
So those 4, but it's a continuum, but those are just
right.
And what if they keep going in different ways? And how do you tell, if you have one in between A and B, how do you tell where your cardinal utility lies? Which one represents?
Are you still working with a representative consumer? That's important. One, you're not getting into the collective utility problem.
No, not
But aren't indices, the real problem with indices, isn't it that it's, I mean, to me, the real conceptual problem is modeling collective preference.
Just take a single consumer, forget the representative question. If you simply have a single ordinal consumer, she's just depicted.
Aggregation issues are a separate issue entirely. This is not dealing with the aggregation issue. This is dealing with changing preferences, and this is dealing with, first of all, what is the appropriate index
I
number?
guess the question that I have is, can you also handle, which is to me the real issue, how do you aggregate collective preferences? Because that's the real kicker.
That's a different real issue.
I don't care if they're changing or not, but
No, there isn't a
That
real
is an
issue.
issue,
but would your method work with a collective group rather than just a single guy?
I'll try to handle that after she.
I think my question is really what match means. I don't know what the word match means here.
okay, what if I had drawn them differently? What if the indifference curves cross?
Well, they cross. Yeah.
What if they cross?
Okay.
You could have, I mean, it's
Sure.
just period 2 preferences look different than period 1 preferences. Okay.
Am I going back one slide because that was, again, for non-experts, that was a little fast.
Okay, so
What's the issue here?
the issue is this is what happens when you have changing preferences. That you can have indifference curves that cross, and how do you explain the fact that the consumer is indifferent between A and C when C is a multiple of A?
Right.
But they're indifferent at different times.
That is exactly the point.
That's the point.
But how do you measure it? How do you measure indifference? You're not allowed to use cardinal utility. You're not allowed to
What
put
is
numbers.
cardinal utility?
I'm sorry. Economists a long time ago became very uncomfortable with the notion of actually consuming utils of pleasure, so that you say that this indifference curve is 7 utils, this one is 10 utils, and I have a number because how do you measure it? So we started working with the notion of ordinal utility, and this goes back to some of the work of Samuelson,
More and less.
where we believe that you can stack your indifference curves so that you have a sense of one being more than the other, but you're not actually putting numbers on them. Once you put numbers on them, you're talking about cardinal utility, and we don't believe that it makes any sense.
Right. So the way that we would say this mathematically is all that matters, I guess you just the word ordinal means, all that matters is the order
Yeah.
And
That's
not-
right.
not
The
yet.
positive
That's right.
Change over to a monotonic transformation.
Positive monotone transformations
Okay.
shouldn't matter.
And, you know, as it turns out, prices will give you a natural metric on the system, but we haven't been able to use that. Sorry.
It's just important to understand, there is a recovery of the cardinal things. It's called happiness. And so there's a huge growing
Happiness?
Happiness, oh yes. And they ask these life satisfaction questions, and there's a lot of work now ongoing in that. You can either like it or dislike
Do
it.
you take it seriously, Richie?
It certainly gives you some very consistent and predictable things. For instance, that being unemployed makes you a lot more unhappy than having a small wage cut. That the divorce or death of a close person makes you a lot more unhappy than other things. Now, whether you take seriously the measures, but I mean, it's giving you something that does fit in general with some things. It's not like it's a weird part of economics, because Danny Kahneman now does this on a regular basis.
I know.
Yeah, I'd say it's a recovery.
Panel studies are more reliable than, let's say, cross-section studies across countries.
And anyway, I think this is getting, if I may, Richard, I think this is a little.
I just want to
Maybe we spend all of the time here.
You're saying you
It's
trust
the
the
one
results.
next to dental right next to
Not just one.
Okay. So I'm going to try and walk you through what the folks at NPOD have developed to help us visualize this. So the problem with visualization in a two-good system is that you have two goods, which is two axes, and prices of two goods, which is four axes. So it's a little bit hard to show on a three-dimensional picture. But what we've done here is we have the ratio of quantities on one axis, the ratio of prices on the other axis, and then the vertical axis will give us, the vertical axis will give us the quantity of chicken in this case. And what we see here is if you take, we've defined a base space in the path, we've defined a path in the base space, which we've simply defined to be a circle in this situation. And we have the blue markings, which are going to show us the substitution effects. And we're going to see how we can decompose our path into increment substitution effects. So, so we see as we move around, this is actually going to trace our path in the base space, and it's showing us our increment substitution effects above that. And the substitution effects, as I said, is the direction that we are going in along the blue markings. And the income effect is going to be the lift. And what we see, if we turn it around, and what this allows us to do is it actually allows us to visualize the extent of the path dependence. So the difference in the rise is going to be the extent of the path dependence.
This is the reference basket above it, so pointing to the income effect is null here is completely by substitution effect. So that what looks optically like an income effect is actually change that you have to make when you visualize the gauge theory. Horizontal no longer means what you would necessarily think horizontal means. But these floating blue squares are defined to be economically horizontal rather than metrically horizontal. What is the blue square?
The blue squares allow you to separate out the substitution and the income effect. So instead of being a flat substitution effect, you're allowing your basket to change at the particular angle that you're allowed to substitute by given prices in the market.
If I stay within the blue square, then there's substitution.
That's right.
The blue square is a way of showing you
sampling the relationship that we made.
That's right.
For clarification for the comments, you are assuming effectiveness.
You can become agnostic and you can say, look, I don't know what generated this seasonal pattern of prices and quantity, but the fact is that I have some seasonal ratio of the quantity, seasonal ratio of prices. That's what gives you the perfect system. And then the point is that you're doing everything to put this in 3D. It's naturally a higher dimensional problem. And so you're going to use only the second coordinate of your basket, given that you already know what the ratio is in the base space. And it's preference agnostic because this is again.
So what I'm worried about is substitution demands are unobservable. I run a substitution on an unobservable. So that's the problem.
The next input demo feels that press the button.
Do you want to take over and show the next input demo?
We
And
just got some demos from the input. So we said, we had something before the conference, and they came in.
go ahead.
I don't understand this at all, I gotta say. I mean, I understand the idea that you move around and you're on some path, but so what? I mean, it doesn't come back to the same place. Now, why
Right.
is it not coming back to the same place?
Because of path dependence, precisely, because you've got a path dependence system.
What is actually, why when you're saying I come back having the same ratio of goods I had before, and during the course of that time, at some point would you have to be buying or selling, or I'm sort of continuously bartering as I move along?
Imagine that you were a hedge fund. Yeah. All right. So then you have to go to cash. Right? And you have two securities. One security, Frank Purdue, I don't know, maybe Steve Angus, right? So you're going to trade off what you're going to hold these two stocks. All right. So the point is that you notice you're only going to trade these stocks off between the two of them, and you may come back, at the end of the year with the same percentage composition that you had in the bit of cash, but you may have a different quantity, right? Because you were successful, let's say, increasing the total number of shares. So, so that would be an example of how to make money through pure bartering, right? Well, so you try to do it instantaneously in something like a currency triangle, or you try to do it through early trading, where these substitution effects, what you could accomplish if there were no subscriptions or redemptions. So then there's the consumer version of this, the investor version. But the key point is, is that any place that you divide into maximization under constraint, right? Horizontal subspace is constraint, and maximization is the vertical. And the point is, and this is really responsive to Bill Daniels, I should say, that Bill is sort of the conscience of this conference, and he wants to understand how this makes the world better. This isn't fancy math. This is just calculus in which rise over run has one determined by the economics, or rather, what are you going to measure the rise from? So you're going to measure it from the economics. So think rise over run. Think whether you think that's fancy math, and think about whether or not you want some off-the-rack version that's always completely level and ignoring the economics, or you want some fancy customized version which uses the economics to determine where you measure that rise from. That's it. Right?
Dawn's question about the specific piece of the basket, that why you might have thought inside the basket about it a certain way and just kind of moved up to a more aggregate view that's smoother.
Sorry, I didn't understand.
No. Okay.
So maybe you can-
There's a high probability I don't get
So-
it.
Yeah.
When we go around the circle, we come back and we're now higher. That's saying it's not an income effect because we didn't actually make money from somewhere else. We made money actually from trading as we moved around. But, or do you call that an income effect or not?
Well, so that's a great question. I mean, at some level, somebody who, the way I talked about this when I was here before is if you have one person who's in charge of client relations, subscriptions and redemptions, and you have somebody else who does the trading, how do you figure out who did a better job if the fund grew from $1 billion to $2 billion over the course of a year? Maybe the guy who lost money trading, but the other guy was so good schmoozing that they were able to build the capital base at some higher level. Well, at some level, you need to be able to tease that apart by saying how much of this was accomplished through the trading behavior and how much of this was accomplished by bringing in additional cash and losing additional cash into the fund.
But I mean, you do calculate the performance based on the capital that you have in the fund. I mean, that's not something.
Well, if you were having continuous redemptions and subscriptions, right? But the key point that I'm trying to get at here is this is the reference best, right? So you have Carl Christian von Weizsäcker saying, woe is us, how do you do any kind of measurement if your gauge changes with the system, right? That's really what he's saying. It's Hermann Weill's gauge, and the key point is that without a market, you have no ability to fill in these squares, right? You can't do the horizontal part of the tangent space. I forgot who says that. The key point is that the market is what allows you to, you know what the vertical is under all circumstances, whether there's a market or no market. But it's only when the market comes in that the system completes to give you that decomposition into pieces. Now, this is not the welfare story. There may be a welfare story that's driving this, but this isn't where you get the added benefit from the welfare picture. This is Divisia's picture, except Divisia is in 1920 thinking only in terms of the base space. He creates this integral, which at some level is controversial. Some people like it, some people don't. But the problem is that people don't necessarily see where this is in terms of a fiber bundle picture, where it's very unarguable, right? This is the first time we've actually ever seen this visualized. You can picture it. But you need two dimensions in the base space.
So you're really pinning down the Divisia index.
That's what this picture is. Then the story keeps going, right? Divisia is
and you're saying let's just go ahead and accept these path
well,
issues.
it's not let's accept it, right? I mean, the point the curvature is really in the economic system. The failure of these horizontal subspaces to fit together comes out of the economics. Just the way you don't have any choice about the flat Earth system. You know, you want to be a flat earther when you know that you're living on a sphere. You're going to take a very inefficient route from Bombay to New York, right? So the key point is, if you want to think about the Mercator projection as real life and the sphere as a distortion, up to you. But the fact is, the economy is really round. Thomas Friedman was wrong.
Okay, maybe let's take some more questions just at this point for Pia before we go on, because I think it's
okay.
We should take questions at this point before we go to more mathematics.
So it's what I'm getting out of this is the use of tensors to try and make everything relational, and so there's no anchor point anywhere anymore. Everything is completely relational, and now you can actually draw analysis from that when things are changing independently without having an anchor point.
I don't know how to answer that.
I don't either.
Yeah.
I get it from a physics perspective.
Maybe let's just hold that, because some of us physicists are going to present our point of view on this, and we will use that language. Okay, there's a question here.
So with the different indices that you presented, like even the very simple ones, like the ones that worked, what if you just take that for a very short amount of time and then repeat that every minute?
That's called chaining, and then at the end of it, if you chain infinitesimally, you end up with the Divisia index.
So for any of the other indices, if you chain them infinitesimally.
That's right.
We do chain. What's bothering me a little bit is that we do chain.
We chain for some things.
Look at the literature, the controversy that chaining arises. I mean, if you go from Barnett, who gets it at some level, right, and you look at all the
people are worried about the Divisia indices not retaining a proportionality aspect. But
No, I mean, you just saw it. I mean, you have a perspective on this. You're saying this is what the real problem is. But I'm telling you, if you look at the literature, he had presented, somebody says this is flawed by path dependence. You really don't understand. And if you're going to try to do this for the Divisia index, when you get to when you get to to two countries trading with each other, where you have imports and exports with two currencies, there's also a Divizia index for that. But you can't form it as an exponential because it has to do with the time ordering operator in Dyson's form of the perturbation theory. So the fact is, this is just the starter, okay? Then it keeps going.
I think there's a huge problem with index numbers. I'm just, to my mind, the big problem is the aggregation issue. I mean, I'm willing to admit that there are people who don't like path dependence, but it's not me. But the real issue is, how are you going to form this? How are you actually even going to form the CPI for a collective? I mean, that to me, that's still...
That is an issue.
Yeah.
That is just not the issue that we're talking about here. And I should say, with respect to index numbers, I think it's very important to point out, as Eric just tried, that this is the first step.
Yeah.
You start off with index numbers, and you realize that you have a gauge theory in your economy. And once you figure out you have a gauge theory in your economy, and you can start breaking things up into increment substitution effects, and you have the notion of economically constant using gauge invariance and using parallel translation, that opens up all sorts of things which have nothing to do with index theory. Namely, it opens up the changing preference issue. It opens up issues of trade. There are so many places you can go with this. And when I said Eric has been following up on this, this is really the first step to understanding it. And you can say, well, okay, so we discovered the Divizia index. But the fact of the matter is the Divizia index is the simplest representation. And it's an easy one for us to deal with because it deals with index numbers. It deals with the so-called index number problem, which disappears. I mean, I think the idea that you can take this and you can apply this parallel translation notion to any of the indexes, and you no longer have the so-called index number problem, is a way of theoretically thinking about it. And then you can actually take it in terms of welfare to say that if you apply if you apply stable preferences to the Divizia index, you actually end up with a Conus index. So there are all sorts of welfare implications of this that you can understand through using gauge theory that you couldn't if you just think of it simply as the Divizia index. So while I agree there is an aggregation issue, that's not really what we're dealing with here. We're dealing with the theoretical underpinnings that allows you to understand the welfare issues of index numbers.
I think the reaction I'm having is that there are various problems that you're focusing on one, and I'll do that when I get to it. But the Fed can't figure out how to do time-varying objective functions with an economic index. It can't figure out a time-varying Conus index. In fact, Franklin Fisher and Carl Schell says it can't be done, right? Because it's the, in some sense, complement of Arrow's problem. Arrow says you can't aggregate, right? He's really answering your question. You can't aggregate preferences of many agents in a single instant in time. Well, what is this? This is aggregating.
You can't represent the area.
Right.
Well.
You say, so then the question, when he asked us, is, wait a minute, you can't do this. Why? Because you're aggregating one individual over many instances of time. Isn't that the same thing as my problem? No, it isn't.
No,
Okay.
no, okay, I'm just
We have a few more questions, and then I'm trying to separate here conceptual issues from the math issues, which just to clarify things. So jump on me if I'm doing this the wrong way, but let's give it a try. So Neil and then Jerry.
Yeah, so I think it's the same thing as path dependence, but if you try to define CPI using this bartering system, you're going to have multiple possible CPIs, is that right?
Using
which? But if you use the bartering equivalence that you were just talking about?
No.
No? What?
You use the Divizia price index. In the simplest of cases, if you have, you essentially use a Divizia price index and you end up with your CPI using a different index than is currently being used. What's currently being used is the Las Peres index. Or you can think of it as using the Las Peres index and parallel translating using a more advanced connection, and you end up with the Divizia index, but you end up with one CPI.
That's the old mechanical CPI. So the Conus index, if you take what they've moved towards, they wanted to do the economic index, which doesn't have a formulation under changing ordinal preference. So what they did is they said, you should use this other index that is so brittle that if anybody changes tastes, it disappears in order to get the savings. So there's the question of the Divizia, which is totally mechanical and doesn't require imputation of tastes and preferences. And there's the Conus, which is supposed to be the gold standard, but is unobservable.
So this
Right.
is the CONUS index. This is what we're trying to get to. We're trying to figure out how to get from A to B. However, we don't have access to preference maps. So what Eric and I prove is that if you use your Divisia index, and if you use the fact that you're understanding it through this concept of changing by economically constant substitutions, what you prove is that your Divisia index under unchanging preferences, this CONUS index only exists if you assume stable preferences.
Right.
So if you apply the same assumptions to your Divisia index that you're applying to your CONUS index, there is an equivalence between your Divisia index and your CONUS index.
So let me try to rephrase that, see if I get it. If you assume the preferences in practice don't move, then the Divisio index will give you point B.
Exactly.
Yeah.
So
If it's under continuous.
under continuous compensation, what we define as the Divisio cost of living adjustment. So if you allow the person, if you're constantly Divisio compensating the person and you allow them to adjust their basket under unchanging preferences.
And that is in practice the same thing as the chain index you said, right?
No, it isn't. That's the point. No, I mean, there's chain, there's mechanical, there's economic. And so the subtlety is that if you just if you just calculate people's Divisia index and they win the lottery, their spam consumption goes way down, caviar goes way up, right? But the point is that that's not going to be a legitimate way of calculating a CPI, so that doesn't get you out of the issue. The issue is, first of all, you don't even have a gold reference if you believe people's preferences shift. So the Divisia index and the Divisia cola are different things to begin with. So you got to sort all of these things out. And also, I should point out that any connection on this space of preferences that I'm going to talk about in a second is going to give you a welfare measure that allows you to do these kind of calculations. It's just that there happens to be a distinguished one. We'll get to that in a second.
Are
Okay,
you distinguishing between cost of living and standard of living?
I'm not at this moment.
Those are two different types of things.
Well, there's cola, coli. I mean, maybe we can.
Yeah, we have so many hands in the air. I'm trying to keep track of it.
Short
Yeah.
question. So is it correct to say that basically the problem is that this index is not coordinate-free defined? So basically you try to rewrite it in a form that you can transport.
It's coordinate-free.
No. The original one. I see a bunch more hands. I'm going to try to intervene as chair and just say what I think the order of logic is, and then I'll call on people. But I'm going to try to clarify because as a physicist familiar with the idea, it's very simple. But I think it's not that you present it in a confusing way, but there's a reverse logic to it. So let me try the reverse logic, which I think simplifies it. You have a system which is evolving in a high-dimensional space, and you have a function. Okay, and that high-dimensional space is this vector space of products cross a vector space which is dual to it of prices. Every product has a price. And you have an evolution in the space of products and an evolution in the space of prices simultaneously. And this could be a consumer price index. It could be a portfolio under trading. Okay. And you want to have a notion of how much has the value of the portfolio changed over time. Okay. Now, since both the prices and the portfolio, that is the vector, which is the inventory, are changing, you have a problem. Okay. And the problem is that you want to preserve a notion of, as you substitute at a given time, you want to have the idea that the portfolio doesn't increase or the cost of living doesn't increase if you trade at any given time things of the same value, of the same price. So there's a space you can move in where the value doesn't change. And you want to figure out how much the value has changed as a result of moving around in these two high-dimensional spaces by always taking into account how to project out the part which is real change versus the part which is substitution.
Right.
Okay. And now, a consequence of doing that, and this is the thing, if you haven't seen it, this is the thing that the visualizations go to, is that a consequence of doing it is that the evolution is generically path dependent.
Yes.
And that's just true. Okay, if you go along different paths of prices and products, even if you come back to the same place, okay, you could have gained or lost in value, and how much you gained and lost depends on the paths that you took. And you took a path that you were in control of what you traded, and meanwhile you're not in control of the prices, which you changed. Okay. Now, the statement is that you just have to accept that path dependence is just true. However you think it out, whether in the language of the price index, whether you chain, whether you do this or that, the path dependence is real. Now, then there are several closely related statements. One is that there is a mathematical formalism which is very general for dealing with these kinds of problems where change in the value of something is path dependent, which goes under different names. Mathematicians call it connections, physicists call it gauge theories. Okay, that's statement one. Okay. And what they've done is apply that. Statement two, in some classes of problems, there is a natural choice of this additional structure. There is a generic natural choice of additional structure with the principles of the problem point out. And that they also have employed. That is, there is the statement that if you move only by substitution effects, you don't gain or lose in the total value, gives you a natural connection or a natural gauge field, which you can use. And the third statement is that one reason this is, at least my understanding of one reason this is confusing, is that there are assumptions that often go into equilibrium economics that are equivalent to no arbitrage, okay, which are imply path independence. That is, if you're really in equilibrium, if the market is perfect, et cetera, then that has an implication that there's no path dependence. Okay. And in the mathematics or the physics, we have a language we're very used to talking about that means a certain function, which is a function of this connection, is zero. And you call it arbitrage, as you economists call it, or traders call it arbitrage, and we call it curvature.
Is that true, or does no arb imply that fluctuations in those preferences are random? I mean, they could.
I'm not.
There's a problem here because you're also introducing problems that don't need
Okay.
to be.
Anyway, let me shut up. That was my attempt to.
No, up until the end.
Now, these two guys, Sasha and then.
I may have missed something, but I thought it was said that in this white curve for the blue lines, there was no market. So if there is no market there, then where the prices are coming from to construct the...
No, if there were no market,
yes,
right, then there would be no squares. And it would be very unclear what the one dimension in the base space meant. Because it was,
so there is a market.
So there is a market. But the really, everybody comes to index theory as if they're visiting a Rorschach test. And people will say, well, I think the real problem is this, I think the real problem. Pull way back, right? The key point is you're trying to maximize under constraint. Okay? That's it. Now, the fact that there is formalism, that it's a version of the calculus, we don't tend to think of gauge theory as advanced calculus, but that's really what it is. And it's the calculus that was made to do economics. The next application, which is going to get to what Lay wants to do, which is how can you talk representative consumer, as Bill was saying, and still know that Arrow's theorem is out there lurking to eat you, right? This is where you get into really funky stuff. So this is the first application. Then there's a trade application, which is the non-abelian rather than the line bundle version of the theory, where the group is just the real numbers, positive reals under multiplication. Right? Under trade, it's 2 by 2 matrices under multiplication that are non-degenerate. So that's GL2R, and it's non-abelian, and things get sexier. And then when you get to human beings, which is what we're trying to do in the session on Homo economicus and Homo selectus, you got to be able to change your mind, right? And so that's the part. Can I do that one? I'm
going to go through these rounds of questions,
right.
and then, because I want to make sure the basic is clear.
A very short question on clarification. What's your base space?
In this case,
we can talk to Chris. I mean, the
price vector is normal to the budget cycle, right? So are you talking about the price vector and the orthogonal?
So we asked NThought, can you guys do 2 goods and 2 prices, and then in the base space, and 2 more goods in the fiber? And they said, as good as we are, 6 dimensions, you can find another company. So we said, okay, how do we reduce the problem? So we took the fact that we could do ratios. So we brought it down from 4 to 2 in the base space, because you need 2 dimensions to be able to see curvature.
So the base space is a price vector and a quantity vector.
Price vector and a quantity vector, and you can reduce them by 1 dimension each by working with rays rather than actual vectors. So you can projectivize twice to cut down, right? So it would be 2n minus 2 generically. Here n is 2. So 2 times 2 is 4 minus 2. Check my math. All right. And then the idea is that rather than plotting both quantities in the fiber, we said, you know what, we're already telling you the ratio, so you only need 1. So we just squeezed in and got 3 dimensions.
Second, a short conceptual question.
Sure.
When I mean, the path dependence, I don't think we normally mind, other than compensating variation, for example,
Okay.
is path independent by the properties of fiction dimensions.
So the issue with path dependence, and which is why we're getting no traction with Lee here, is that people want to say things like the price level. And in that linguistic crime, right, there hangs a tail. So if you believe that the price level exists, and this is supposed to measure the price level, you're back in the 1920s with Irving Fisher saying, I want a thermometer that tells me how prices have risen. Well, if some prices go up and some prices go down, where is the price level? It's an ill-posed problem. So the key point here is to understand it's not about index numbers. It's about constancy. It's about the right tool, right? We are not here with a screwdriver looking to screw in some nails. The fact is that people have been screwing in nails since the marginal revolution, right? This is a hammer because there are nails. That's it, right? And you got to figure out how to use it. And it also doesn't solve index number problems between agents or countries, right? So we don't have anything to say if there's no path connecting 2 states. That was one of the questions that Arrow had. And we said, well, if you have a bunch of different agents and you have a path that transforms, you know, Bob to Alice, Alice to Carol, Carol to Ted, well, you know, and you have prices, which is something that Arrow didn't have because it was a social choice problem rather than a market problem, then I can solve Arrow's theorem just the way we solved this.
Okay, 2 more questions and then we'll go on. Yeah.
I had just one general comment, but now I have a technical comment. So like you said, that arbitrage prices, non-arbitrage prices, and equilibrium prices are very different things. And equilibrium is much stronger than non-arbitrage. Non-arbitrage is a general statement, very weak, that just says, and by the way, it's independent of inflation, because it's a numeric invariant, as it says. It just says that if you have 0 as your starting value of your portfolio, you cannot make a portfolio for which in all the states of the world you don't lose money, and in some states of the world you make money.
Without spending anything more. So starting from nothing, you
Starting from nothing.
Anyway, I apologize for my ignorance. I stand corrected.
Now,
what you want
as
to say.
for the general comment, because the talk started very ambitiously with foundations of what is economics and changing preferences and so on. But then it quickly converged to one way of seeing changing preferences. I just want to understand and situate it. So there's a large industry of looking at time-consistent risk metrics and time-consistent utility functions, and all those things represent preferences. So there are things like forward utilities that satisfy a differential equation, or risk measures, dynamic risk measures, and so on and so forth. I just want to know, are you brushing that all aside because you don't want cardinal utilities, or because you're restricting yourself to?
No. This is an important problem because there's a political angle on the problem, which is I'm trying to get a debate with Gary Becker or Dale Jordan or somebody who will get up and talk to me about how we talk about CONUS indices and cost of living, when the claim is in the literature, as you saw from the Fed and I can show you Carl Fisher and Shell and von Weizsäcker, all of these smart people, this tiny group rather, who talks about changing preferences, says, you know, we don't have a theory, right? Now I'm about to do, very quickly, where we get changing preferences. And this is going to keep on going, right? The next thing is that the welfare measure, the gauge field, as Lee talks about, is going to become dynamic. And it's not going to be that there's necessarily one canonical welfare measure. Maybe the welfare measure becomes part of the societal structure, right? And what you say is as good as my old situation changes dynamically, right? So the idea is you can work in a fixed background. So lots of stuff is coming, but we can't, part of the problem is that this problem is solved the wrong way in the field now. So we have to basically point out, you know, you don't have a theory. You have a theory for robots that don't change their minds, right?
But suppose I'm not interested in this particularly idiotic group of people who don't like
Well, we're not going to call it neoclassical economics.
Eric, can I make a try? Because I think you're bringing in policy and debate. The answer is yes. The answer is that the proposal is that everywhere there is time dependence, okay, there is curvature. There is curvature that is path. Curvature is another word for path dependence. And everywhere where there's path dependence, there is a mathematical, a well-developed approach to dealing with it, and their proposal is to employ it.
Here.
Okay.
Are we having a group discussion on this?
I hope so.
I have a lot to say about this because I've been working on this, basically defining precisely the notion of curvature for arbitrage in finance, and precisely I find your connection arises in this case too.
Which connection?
The
one that Lee called Malaney Weinstein?
Yeah, the one
so
the visa index.
There's more stuff coming, so it's not. That's not. So
you will get a chance to present that either right now, or if we run out of time, we'll find the time.
So
and other people. Okay, last.
So does this mean the consumer price index is something that is path dependent on how the individual preference of a particular agent changes over time? In other words, you could calculate it for one person at two different times.
The current CONUS index, right, is dependent on one preference map, which never changes.
Right.
Full stop.
Okay.
There is no current that we are aware of in the literature. One of the reasons I'm very uncomfortable about this is that I can't imagine that it doesn't exist. But we believe, having done due diligence, that there is no approach to ordinal welfare with changing preferences, evolving preferences currently in the literature. So we have apparently based the US CPI on substitution effects for a mythical consumer that does not exist and must not change its preferences by completely finessing the issue of preferences and using something called superlative index theory, which is only relevant for this unchanging actor, provided they always consume the same relative amounts at every level of income.
So I buy that there's a methodology now for calculating for a particular agent who has changing preferences.
You do?
Yeah.
But I haven't shown that to you yet.
Well, he's a physicist.
Okay. So let me do that, because that's okay. So
what it means is for a particular agent. So if you wanted to compute something like the CPI, you have to do some kind of path integral or sum over path.
Oh, see, I like this thinking, but so let's get to the sexy stuff, right? At some level, how are we going to deal with these things, and how much physics is this really going to take? Okay. So before we did V cross V star minus the bad set, where things were degenerate and the basket was valueless in the pricing system. And we had over that.
Eric, we can't see from this side because of the screen.
Start on the other side of the board and do it in Arabic.
Okay.
It's easier to understand.
What? I am going to use the screen again. Okay. What you really want to do is to define some kind of a preference space of ordinal preferences where every point here view it as a little picture of a system of indifference curves. Whether you think of it as a foliation or a preference map, up to you. Okay? Now, somebody said cardinal utility is related to ordinal utility based on the insensitivity to anything other than the ordering, right? So it's, in fact, the way I would like to say it is invariant under a group. What is the group? The group is the reparameterizations of the positive real numbers, right? So the key point is that ordinal theory, ordinal welfare theory, is the base space of a principal bundle with a dangerous total space, cardinal utility theory. And these things are called fibers. Now, in what Pia did, we were dealing with a vector bundle. Economists don't deal with groups and group transformations much, but this story is much more natural in the principal bundle formulation of gauge theory, right? So the idea is I've got a giant space of functions, honest to God increasing functions that end up in the real numbers. So each one of these is some sort of a function that takes the same space of goods to the real numbers. Right?
So preference.
A cardinal preference function that attaches some number of utils and always attaches more to higher curves because more is better. Now, if I mod out, if I push these things around by increasing functions that go from the reals to the reals and are one-to-one and onto, right? Then the point is I'm left with the contour maps generated by a giant family of different cardinal functions. So the gambit is that in order to do ordinal welfare, you'd venture into the dangerous territory of cardinal welfare. But you have to make a promise that in order to get back to ordinal welfare, you're going to work under this G action and make sure that everything you do is insensitive to which lift you choose above the base space. Right. Everybody's got different languages. So the point is that if there were a connection on this space, you might be able to move from one point on this fiber to a point on another fiber, and if you started at a different place, you could end up in a different place. Now, you always had, in the old cardinal theory, the ability to say, I'm going to take cardinal utility at time 0, and I'm going to compose that with the inverse of the cardinal utility function at time 1. Right? And 10 utils of happiness then maps to 10 utils of happiness now, and I have a one-to-one correspondence between the level sets of my two functions. Right? Okay. We'll start from that. So imagine.
You're looking for an eraser?
I am.
There is one.
Okay. Right.
Before you erase anything, can I connect this back? In the path of the Divisi index that you had before, is that going to be in here? Is that going to be going across the fibers, or is that going to be moving up and down a fiber? Or is it completely something different?
The Divisi index is purely mechanical.
It has nothing to do with this. It's not moving
No,
up
it
into
is.
space.
It's all related.
Around these points, or is it something completely different?
It's related, but the point is that there's going to be some map, the Marshallian demand map, right, from preferences together with prices into goods.
Are you going to be moving up and down a fiber? Are you going to be moving across fibers? Or
I'm going to be moving across fibers.
Okay. Moving across the fibers.
Okay. Now, start with this. So this was always available back when we believed in units. The next thing I do is to say, you won't begrudge me putting the identity function in the middle of that. That changes nothing.
This C or G or whatever it is this.
These are two cardinal functions from the positive orthant of the vector space onto the positive reals, giving the amount of utility in a cardinal.
Utility.
Yeah. But utility cannot. There's another game where instead of utility, you use cost as your dollar marker, and you use something called the cost function, right? So it really, I should abstract it, but think of it as utility to begin. All right. So this has no problem. Now, you're not going to begrudge me if I put an upsilon in the middle of this and I say upsilon is equal to the identity. Right? Because I'm just playing games.
Aren't you just automatically solving the index number problem by assuming this identity matrix? I'm not quite sure.
Wait.
Begrudging.
Okay, wait.
This is a magic wand, isn't it?
No. I'm just, this is tautology land so far, right? And then I'm going to get to Herb Gintis. Okay?
Now,
So
C0 to C1, you're saying is absolutely trivial?
No, C0 maps into the reals. Then I map out of the reals, and I get another curve, right? So that's, if I believe the cardinal utility, is very easy. You were 10 noodles happy, yesterday. Now I'm going to have to compensate you for 10 noodles of happiness today.
Maybe you should draw a map of that mapping.
I don't know if that's what you wanted.
Beautiful.
It was good. It was right behind.
Art has always been my best
As long as you
subject.
have absolute cardinal utility, this is not controversial.
I would think not.
Controversial is believing
Okay.
that you ever could.
Now, the point of this is, now this is set up for an old, some observations of Amartya Sen and Herb Gintis, right? So let's think about the manic depressive. The manic depressive who has no taste change experiences different amounts of happiness consuming the same damn stuff because that manic depression is encoded cardinally. What measures, and I think this is Gintis's term, man's efficiency as a pleasure machine? Man's efficiency as a pleasure machine could be this thing rather than the identity map. So if you had a definition that wasn't philosophical, but was actually computational for man's efficiency as a pleasure machine, you could stick that gadget in the middle of this comparison, and you could potentially, if it was dependent on the way you got from C0 to C1, have a completely ordinal measure because the paths would be related under group transformations. And so the illegality, right? I remember that I'm going into the illegal cardinal territory, but I'm going to pay it back through gauge invariance. So that the ultimate comparison, if I had two different, so
This is no longer identity matrix.
Pardon me?
Right. Is no longer the identity matrix. We got rid of that. Good. I never liked it in the first place.
Me either.
Good.
Okay, right. So the whole point is that this is, and for those of you, I broke my pledge to Bill Janeway, but think of this as a giant XYZ plane, right? We're down here, I've got X and Y, and this is some crazy notion of Z, where all the fibers look the same, but it doesn't have any trivial connection. There's no trivial notion of horizontal to begin with. Pia's example started with the idea that I had a connection called the trivial connection that allowed me to write down all those cockamamie index numbers, and then I would do something through projection maps to adulterate it to get the economic connection. In this framework, we're in infinite dimensions. There's no initial connection on this space, and in fact, any connection will give you this, but there is no natural connection. I conjecture that there's no natural connection. However, there's one piece of information we don't have, which is an income expansion path. So you put in an angle curve, right? So the right ordinal base space is ordinal utility functions with cross sections, which is equal to preference maps with some cross-section that touches every leaf once, starts effectively around the origin and goes off to infinity properly. On top of that, I have pairs of a cardinal utility function, C, together with a map X from the reals into the vector space, into the positive orthon of the vector space, subject to the condition that it's a right inverse. That is, mapping from the real numbers into the vector space, followed by taking the cardinal utility is equal to the identity transformation on the real line. Okay? So this space of pairs
is an infinite dimensional principal bundle, effectively patterned on the Diffie. Sorry, I hurt my mask.
Gary Becker.
Okay. We got an infinite dimensional principal bundle, right? And the claim is that this gadget here has a distinguished connection, right? So this space of two functions, one into the vector space and one out, continues to have an action of the group of the reparameterizations of the space utils, has a natural connection, and for any path in the base space, any path that covers it in the total space, you can compute a special correction element so that that corrected path is completely horizontal, right? Sorry, Bill. Nothing I can do. So the idea is that that correction factor is all it takes to create an ordinal theory. It looks cardinal, but each choice of a time-dependent cardinal utility function corrected by the canonical connection gives you a welfare comparison map that is insensitive to the choice of cardinal representative for the ordinal path. In other words, you got ordinal time-dependent welfare theory. I can change my preferences finally, and I can build realistic models without the threat that the entire edifice of neoclassical economics is going to collapse. Now I want to get to Lee's question. There are two funny refinements, and this is going to sound like it's in such poor, where's my eraser? Poor taste. But my claim is that it's kind of, I think it's kind of astonishing that this toolkit works just as well in economics as it seems to in physics. It's just as natural. And if you think about what C.N. said to Chern many years ago, he said, I can't believe that our entire theory of underlying reality is all based on principal bundles, given that you guys had no idea that you were modeling reality. And Chern says, no, 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 we always knew that this structure was so natural that it had to be. It wasn't a choice. Okay? If I have preferences in the base space, what happens with the seasons of the year? I know that I'm going to want to buy gifts in December, or if I don't want to buy them, I'm going to have to. I know that I'm going to want summer wear and sunglasses in June. So are my preferences a single point that goes on some sort of a trip and comes back close to where it is a year later? Why not just start with the idea that I know I'm going to have December preferences? And so I have some loop in the base space of all ordinal preference maps that represents me. I know something about my preferences in December, right? So I've got a one-dimensional extended object in the base space of an infinite dimensional function space of a principal bundle. Now further, Lee wants to know what happened to that representative consumer. We're damned if we do, we're damned if we don't. If we don't have one, we can't work. If we do have one, we're contradicting Arrow in some way because you can't find commensurate representations of preferences. Well, who's to say that a single preference map should be thought of as a point? It's equivalent to think of it as a Dirac distribution whose support lives at a point. So I've got 100% of my probability at a point, and I'm going to call that a point. Well, why not relax that a little bit? Maybe the idea is that I've got some sort of a wave function, analogous to a wave function, living on preference space. That's what I said to Bill before.
It's just a probability distribution.
It's just a probability distribution.
You are reminding me.
Don't go quantum on us.
No, I'm trying to, it's an analogy, right? But the point is that now I have the idea that I have to propagate a probability distribution, maintaining probability, if I want to have a dynamic representative consumer that makes sense, where the consumer is instantiated by pulls from the distribution.
Got it? Okay. There is a literature on this, actually. It's called state condition utility, and also there's distribution. Warner, the German. No. Anyway, I mean, there is literature now that you put it this way.
Hildebrand.
Yes, okay. But there is literature on utility functions conditioned by state. And so
Well, Gary Becker wants to do utility conditioned by state because he's going to have some variables that are exogenous to my societal relationship and some that are intrinsic based on my personal
so, I mean, your
improvement.
circular loop here is if I think it is, if I really think it is seasoned, it has been looked at that way.
I'm not, again, my point is in part to try to talk to many different issues simultaneously.
Yeah.
Somehow we are looking at lumps of probability that have to move dynamically without losing probability. And they may be defined not on preferences, but on loops of preferences in order to
Do they have to be loops? Because Becker himself has a theory of rational addiction, where, in a sense, the agent says, I know that if I start consuming this thing, I'm going to want it more.
Right.
But I make some higher level decision about whether I choose to become an addict and allow my preferences to change based on that consumption. So that's not a loop. You go off a certain direction.
So there's an open version of this and a closed version of this, right? But the point that I'm trying to get at is that to a physicist or to a mathematician, this is quite striking. Suddenly, I'm in infinite dimensions. I'm in the base of a principal bundle. My objects are extended objects, and I'm worried about propagating probability distributions without losing probability, right? Now, the point is that I didn't get there by saying, boy, would I like to port my whole toolkit from physics into economics. You get there by saying, what does it mean to have a representative consumer? What does it mean to have seasonal preferences? What does it mean to change my mind? All of those things, naturally, if you build with Lego, and this is one of the whole points of trying to get this discipline into this conference, this all comes out of the idea that you're dealing with calculus and linear algebra in your model category. Somehow, by making those two innocuous restrictions, that I'm going to deal in a fiction in which everything can be done in the reals rather than over the integers of the rationals, and that I'm going to deal with it linearly algebraically, those two innocuous decisions end up rebuilding a giant chunk of what we think of as the physics toolkit. It's how we see the world. It's the space-time continuum versus the space-time continuum. There is, strangely enough structure in these systems to put us in direct context. Now, in 1976, or thereabouts, Jim Simons, Cian Yang, Wu, whose name I can't remember, first name I can't remember, came up with this correspondence. Bob Herman had seen this somewhat earlier. And when Singer took the BPST instanton, which turned out to be the quaternionic Hopf vibration, to England to see Michael Atiyah, sorry, I'm gone, right? That started this whole revolution in mathematicians and physicists talking to each other because they had some sort of a canonical object. And it started off as a distinguished object, but then the desire to push the distinguished object around to gauge transform it became irresistible. And it created an industry which is still with us to this day, which has been hugely productive for both fields. Now, nobody, I think, saw that economics is absolutely in the same position to play the game. This connection is the BPST instanton for economics. And let me tell you, it's a hell of a lot sexier than the BPST instanton pseudoparticle was for theoretical physics and mathematics. Now, if you think that that's wrong or that's funny or that everybody knows it, take a look and tell me where to find it.
Okay, let me propose at this point, we have about 10 more minutes in this session. So Pia and Eric are making a big claim. Why don't we have some response discussion, and then I think when we go back into groups, we're going to add a group which is discussing in some detail about gauge theory and economics and so forth, which is okay. So Dwayne?
I don't know. I guess the question I'm asking myself is if I want to do science and not math, does this really matter very much? I mean, I'm convinced, yeah, that this is the right way to do indexing, and the chain geyser helps maybe some clarity in that, so that seems okay. But I guess, what else? I mean, the fundamental question is really, do we believe that we can understand utility from some functional point of view well enough that we can really do models, and so that we can account for framing, or the fact that when I walk into a casino, I'm risk-seeking, where normally I'm not risk-seeking, and can we really measure this stuff well enough that we can go out and do some practical things with this so that it'll really, is that what's, I mean, was this really what was broken with the main theory? I think you're claiming that. I mean, clearly it's a, you know, a nice enhancement.
No, there was no welfare theory for changing ordinal welfare. So the point is that I can make a conjecture, which I can throw out, which is that given only prices and ordinal preferences, that this is the only constructible welfare map available to you. Now, you may not like it, in which case you don't have any welfare theory, if I'm right, or it's a challenge to build.
Well, I question the whole theory, so I'm just wondering whether we really ought to be.
I think you want to make a different challenge to me, which is you and I are in some sense allied, but in some sense at polar opposite ends of the spectrum. I think that the question you want to ask me and the one I want to answer to you is, this opens up, no, because you want to predict something, right? What is the effect of advertising on the human mind? What is the effect of things that push around our preferences? If you don't have a welfare theory, you're not moved to say, what is the physics of mind that can try to figure out? Now, the fact is we spend a huge amount on advertising, and we come up with these elaborate theories to explain away the dynamics. Well, what I'm trying to say is, what I want to get to is a physics of mind which talks about how our preferences are shifted in the world, what shifts them up, down, what changes our welfare. And the idea is that I'm going to have to drag along this structure.
It seems like, I mean, maybe just what you need is a proof of principle. You need a demo that this actually does something useful.
So a simple example is what...
I'm going to call on Pierre. And
Richard has a question.
Yeah, this is very similar to the question just given. If you go back to the index number issue, and Eric said, okay, the world is curved, it's not flat. And I immediately thought, yeah, but from getting here to the hotel, it's flat. And so there really is a quantitative question of where you want to say, how much does this matter? First, to this initial problem. The issue of, I appreciate the issue of opening the door to where we can start talking about and hopefully measuring preference changes is exciting and so on. But just to go back to her original sort of thing, how flat, we have a demonstration of how flat versus how in the curved world that truly exists. You know, are we doing a bad job with the divisive things? And how, if you were on that commission, would you have said, nope? By the way, the real thing is that the CPI wasn't going up by this phony 1.1.
It's a gift of a question. It's a great question. We got into trouble because we were trying to help them, right? We said, you want to shift the cost of living from a mechanical? That's a good thing to do. And you can't do it now because preferences shift and change. We'll help, right? In fact, if you look in that report, they do an example with chicken and beef. And what they say is that here is your chicken and beef and your prices in period 1. Here they are in period 2. And here is the estimated overstatement. Okay. So you say, well, where are the preferences? They say, we don't need to tell you about preferences because DeWert did such a brilliant job with superlative index numbers. You say, no, that's not true. He may have done a brilliant job, but you haven't showed us what that difference is. So you say, let's try to back out what the preferences were. Assume Cobb-Douglas as if this was a simple class, right? If you put in Cobb-Douglas preferences, you can back out an exponent. Does that exponent stay constant? No, it shifts. How can you visualize the shift? Where's Robert Kern? Robert Kern figured this out, had to demonstrate it at 4 a.m. So, big hand for Robert Kern. Now, all right, sorry. Inverse class. So here, you're consuming price of beef, chicken is equal, same quantity, budget, COLA, alpha is the exponent of the Cobb-Douglas function, and you linearly interpolate prices and you linearly interpolate alpha, and using the connection on the infinite dimensional principal bundle over the taste-time continuum, blah, 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 you manage to pick out the isoquant, the indifference curve, which exactly tracks using this distinguished connection on cross-sectioned ordinal preference space.
Could you say, I mean, are you computing this from some data, year by year on
I compute prices? No, I said I linearly interpolated the exponent, and then I solved it exactly closed form. I said, we're different. So at some level, I came up with the problem that allowed me to get back and forth between the two alpha exponents for the Cobb-Douglas.
Yeah. So like what I'm asking myself, let's suppose during the course of that time it came out that chicken is really healthier than beef.
Right.
So preferences really switch.
Yeah,
okay.
right.
How would you know that from the data? How would you actually would you be able to have the data every year? We sample what people are paying for chicken, what they're paying for beef, how much they're eating. You're saying from that data you can do this correctly.
Well, no. What I'm saying is that the economists would tell you all I need to do is to find some continuum of consumers to line up along the income expansion path, the angled consumers, and then I have to divisia compensate them, constantly paying them their divisia adjusted fixed income, and watch what they do in the markets to gain access to the preference structure that they all have in common, right? And I've got poor guys, rich guys. That's what the economics tells you to do. Is that total nonsense that is never going to happen? It is total nonsense. It will never happen. But even that total nonsense that was as kind as could be, that could never happen, wasn't solved. Okay? So the first thing is that in terms of welfare theory, you see, welfare is in some sense a human construct. So it may not have the same kind of observable consequences that you are going to crave initially. But what I really always wanted to do, and what Pia always wanted to do with this, was to get past all of this formal stuff and to say, when are we going to do the harmonic oscillator for the mind? What is snob appeal? What is mass appeal? Right? What is fear and greed in these shifts? I always hear about, we've gone into risk-seeking mode. We're now risk-averse. Well, we don't have any physics of this mind that allows us to figure this out. We need heterogeneous agents that are moved by exogenous events, right? And we need to have some understanding of how to do equations in these spaces that propagate things like strings and probability distributions without losing probability. What I've been trying to say is, who knows how to do that better than my friends the physicists? Nobody, right? So the point of doing this in a physics institute is that this is the Willie Sutton point. If you're going to rob a bank, go where the money is. This is the kind of a place that knows how to do this stuff. And they just never thought, I think, of looking at something, and again, it's a quantum analogy, don't shoot me, of looking at something like quantized strings in an infinite dimensional principle.
Okay, let's take one more question, comment. I'm going to take, we'll have two, because I saw two hands on things. You right there, Steve.
Quick. It doesn't seem like you answered Doyne's question. Is there an empirical set of things you could do to tell whether preferences are shifting? One person, you're just watching one person over time. So you don't forget about aggregating,
sure.
Just one person.
You hit them with the same problem on 2 different days, and they do 2 different things. Done.
But they're not actually in the same state, is the real problem. They're not in the same environment. You'll never get them.
Sorry, the ordinal preference is sliced. I mean, if you want to use a Gary Becker style utility function where you come up with extra, I mean, how can you tell that everything isn't going around the Earth? If you give me enough epicycles, I can do it too, right?
What I'm trying to say to his question is if I actually have a state-dependent utility and it depends on my path of consumption, then you'll never be able to test me because I'll never step in the same river twice. I mean,
Right. So then the point is that you can't do economics and we can all go home, which is what they've always been afraid of. What I don't get, and the thing that really upsets me about this.
I did go to Wall Street.
Wait, no. Just so you understand this, is I find it fascinating, and I think that we're running an experiment here. Have any of you ever asked these questions at a neoclassical seminar?
Yes. Have you ever actually?
And were you satisfied with the answers that came back?
Of course not.
Are you more satisfied with this?
I'm intrigued. I don't know what
I knew there was a group hugging you. I'll hold you to it.
Okay.
I will tell you.
Sorry, I keep saying, but Matthias.
in 1970.
So back to the problem in cardinal utilities. I think ordinal utilities is too difficult, so I never dealt with it. And then cardinal utilities is slightly easier. But I want to propose a further simplification, an example of that, which is expect utility by expected value. So that's an even simpler function. You just go from R to R, not from the positive order to R. But I want to say that there's a time inconsistency there that maybe wasn't addressed here, because you're talking about solving problems at one time and then looking to another time and solving problems again. I want to address what happens when you need to solve a problem that requires decisions to then be followed up in time. And the problem here is the following, that utilities, individuals are impatient. So the utility have a discount factor.
Right.
So if I'm just looking today and tomorrow, for my utility today, I might say that I prefer $10 today than $12 tomorrow.
Right.
$12 tomorrow is not enough incentive. Okay, but then say that this requires me to commit to something that will happen 30 days from now. Now, from my utility today, there's a decrease in function. So now the difference between $10 30 days from now and $12 31 days from now is not that much. So my preference reverts. Right, so I prefer to have the $12 31 days. And I say that's what I'm going to do. That's my strategy. When I get there, it's not that anymore. I still prefer $10 than the $12. So there's a fundamental time inconsistency. And let me just finish. So there is a class of utility of discount factors for which this problem doesn't arise, and it's the only class, which is the exponential class. So when you write the HDB equations and so forth. The problem is that exponential discount factors are not empirical. You go and you measure things, and then individuals have power law decay in this hyperbolic discount factor, power law stuff. So what do? So you need to come up with an extended theory of time consistency utility, and I think that adds a complication that you assumed that was entirely trivial, because it's just you have happiness now and happiness then.
I'm even moved by the simple problem of von Neumann-Morgenstern subutility functions, which are somehow mysteriously allowed to show cardinal happiness to the point of viewing doing risk calculations. But if you're not doing a risk calculation, then you say, oh, well, we're not allowed to assign that because that's only an intermediate stage of a problem. The entire theory of utility is messed up. It is, and you know it, and I know it. Now, what I'm trying to say is different, right? What I'm trying to say is, in the session on Homo economicus and Homo selectus, I want to talk about antagonistic pleiotropy and trade-offs between vigor and longevity, right? Which is where discounting should probably come from. Is it true that we never face these precise problems in the EEA, so we're not particularly good at solving them? Yeah, I agree with that. What I am trying to say is, I'm trying to go in as a conservative revolution, not as a behavioral revolution initially, to just say, you know that thing that you could never do before, now you can do it, okay? Now, something about that process unleashes something in the collective economic unconscious, where everybody asks the question, well, wait a minute, can't you solve all the other problems that have always been with us? Well, if we start being honest about where our problems are and really trying to deal with it, we'll have a hope. And I'm going to try to do that in multiple places. But the fact is that even in fictitious ordinal utility theory, you couldn't solve the problem of a changing agent. So the agent couldn't become biological. And you could either opt for a Gary Becker-style solution. One of the things that's very difficult being in opposition to the Gary Becker-style solutions is it's not that what he tried to do was totally wrong. It's just that it needs to be refactored and done right? At some level, it's like false Darwinism. Darwin was so good that he got it right the first time. But what if somebody had incrementally kind of gotten a lot of it and screwed it up really badly? Well, that's really what Gary Becker in Chicago did. We are facing these sorts of trade-offs. We do need to think about them rationally, but the theory wasn't mature enough to make all of the extensions and to start dominating the social sciences that didn't have the math. So what I'm trying to say is help is coming. The guys with the math can try to sort this stuff out. And now you've got real biological problems, which is to try to figure out how should I think about welfare if everything is changing, which we have to solve, and we don't have a good theory for it.
Good. I'm going to give Dwayne the last comment.
So I'm really embarrassed, but I have to just comment on what you just said, because it happens that John Giannakopoulos and I have just finished a paper where we address what you just said, and the solution we come up with is if you assume that your instantaneous discount rates are fluctuating as real discount rates do, like interest rates, then, and if they follow a geometric random walk, we can actually show that when you look at the certainty equivalent discount, you go from an exponential to a power law. That is, hyperbolic discounting just falls out of it. And so it's, I'm sorry, it was just your question was so directly relevant, and we just finished that paper. So now this may have some connection with what we just heard about. I realized is
I'd love to link up.
connecting that. So
Okay, very, very good. So first, thank you, Pia, thank you, Eric, for